In this video we are going to see about the Tower of Hanoi. This is one of the main application of the regression, as well as it will come under the application of the stack. So here you can see the figure. So there is three poles, that is A, B and C. So here pole A is a source and pole C is a destination. Okay, and this pole B is a spare pole. So here what we have to do is we have to place the ring from A to C in the same order. Okay, so here the problem is to move all these rings from pole A to pole C while maintaining the same order. We have to maintain the same order. And one more thing, we should not place the biggest ring on the smallest ring. Okay, so we have to maintain this same order. So here main issue is the smaller disk must always come above the larger disk. So here what we are using one more pole, that is a spare pole B. So here is A is a source pole and C is a destination pole and B is a spare pole. So here we are going to transfer all the three rings from A to C. So we will see how we can transfer. Consider third pole. So this is A, B, C. First what we are going to do is the biggest pole and smallest pole will be in the pole A, and I am placing the smallest pole in the C. It's the first step. In the second step what I am doing is biggest pole will be in the pole A, the medium pole I am placing in the B pole and smallest pole is in the C. In the next step what I am doing, the biggest pole is in the A pole, biggest ring is in the A pole, okay, and medium is in the B pole and small will be in the top of the medium. Okay, then the next step, okay, in the next step the biggest ring is placed in the pole C. Okay, and here the smaller and medium are in a pole B. In the next step what we have to do, the smallest ring is placed in the pole A and medium is in the pole B and biggest is in the pole C. In next step, okay, in the next step biggest ring is in the pole C, then medium is in the pole C, then small will be in the pole A. And in the next step, okay, in the next step what we can do, first the biggest one, then medium, then small one. So like this way what we have to do, we have to move all the rings from pole A to pole C. So this is the procedure. And next what we will see, what are the rules available in the Tower of Hanoi. So here at a time only one disk or one ring can be moved from the pole. Okay, only one ring can able to move from the pole, and each move consists of taking the upper disk from one of the stack and placing it on the another stack. So that is this can only be moved if it is the upper disk on the disk, okay, or the stack. Okay, so this can only be moved if it is the uppermost disk on the stack. So no disk may be placed on the top of the smaller disk. Okay, not placed on the top of the smaller disk. Then the solution to our problem of moving n rings from A to C by using the spare B, it can be given as, if the base case, in a base case if n is equal to 1, so we can able to move the ring A to C by using the B as a spare. And in a recursive case, move n minus 1 rings from A to B using this C spare, and another one we can move one ring left on A to C using the B as a spare. Then last one is move n minus 1 ring from B to C using the A as a pair. So these are the cases in the recursive case. By using this only, what we can do, we can able to move the ring from pole A to pole C. So this is the implementation of Tower of Hanoi. So we are using the function move, and we are passing the arguments int n, source, destination, and this pair, and we are declaring the variable n. Then it will print enter the number of rings, and we will get the value from the user. So the n is the number of rings, and here we are calling the function. So we are calling the function with the argument the number of rings, then pole A, pole C, and pole B. When the function is called, it will go to the function declaration. In this function declaration, first we are checking if n is equal to 1. If n is equal to 1 means we can move the ring from source to destination. Else, so these are the statement I told in the recursive case. So we have to process one by one. So again the function will be called again and again till we are reaching the destination. So this is about the Tower of Hanoi.